Hi everyone. In this video I want to explain how a ship is able to swim. First we go to the mountains. You probably also know the phenomenon that the higher you climb a mountain, the thinner the air and the lower the air pressure. These little red figures are supposed to represent the air particles. The deeper you go down the mountain, the closer the air particles are. This increases the air pressure the deeper you are. We assume in water it is also the case that the deeper you are in water, the greater the water pressure and the closer the water particles are to each other. You can feel the pressure on your ears when you dive. The deeper you dive, the greater the water pressure. Before we look at a floating ship, let's first look at a beach ball. This floats on the water surface. Since the water ball only has air inside, its average density is very low. This means that it has a very little mass despite a larger volume. As a result, the beach ball presses on the water surface with a very low weight force. The weight force is so low that the few water particles on the surface of the water press against it strong enough for the beach ball to experience a buoyant force due to the water particles that is just as great as the weight force. So the ball can float. Now let's look at an object with a much greater density, a stone. Let us assume that the area with which the stone presses on the water surface is similar in size to that of the beach ball. Therefore, the same number of water particles push the stone upwards and provide the buoyancy. However, with a similar volume, the stone has a significantly greater mass than the beach ball. Therefore, it presses with a significantly greater weight force on the water surface. Since the two forces do not balance each other this time, the stone sinks to the bottom. On the way down, the water now presses on the stone from all sides. The two lateral forces balance each other out. The force from the water particles which presses the stone down on its upper side is smaller than the force from the water particles which presses the stone down on its lower side. This is because the number of the water particles increases with depth. The two forces lead to a resulting upward buoyant force. However, since the weight force of the stone is greater, the stone continues to sink to the ground. Now let's take a look at a ship. How can such a heavy ship swim? A ship uses two tricks to do this. On the one hand, a ship has a relatively large underside that sinks relatively far down into the water. This allows many water particles to exert a force on the underside of the ship and push it upwards. The second trick is that a ship has a large cavities inside that are only filled with air. This reduces the mean density of the ship and thereby also the weight force. In this way, buoyancy and weight force can balance and the ship can swim.